Good afternoon. So today we are going to start a new topic that is called a section formula. And the first point to know about the section formula, the first point what we are going to discuss is called the section of a line segment. Okay. So what we are going to discuss is called the section formula. And the first point what we are going to discuss is that section of a line segment. Let us first understand what is meant by a section of a line segment. So let us consider a line segment. So let me draw the line segment in a different color. Suppose this is a line segment, and that line segment what we define as A, B. And in this line segment AB, we get a point P, okay, in between AB, such that P divides this point P divides the line segment AB internally in the ratio lambda is to 1. What does it mean? It means is that AP is to PB is equal to lambda is to 1. AP is to PB is equal to lambda is to 1. So this AP and PB, they are in the ratio of lambda is to 1. Mind it one thing, dear students, is that AP is not is equal to lambda and PB is not exactly equal to 1. It maybe may not be, but they are in the ratio of lambda is to 1. That means we can say AP could be lambda k and PB could be 1k. Means we can say AP could be lambda k and PB could be just k, where k is a real number. K belongs to the set of real numbers. So this is what is called a section of a line segment. So what we can say from this diagram, we can say that the P divides that AB in the ratio of lambda is to 1 internally. Okay. So from this statement, what we can say is that this implies that P divides the line segment. P divides the line segment AB in the ratio lambda is to 1. Now, let's consider AP is equal to PB, M is to N. If AP is to PB is equal to M is to N, we can easily convert it to in the form of lambda is to 1. Then what we can say? From the ratio what we have learned, from here we can say AP is to PB is equal to M by N is to 1. So that we can get that it is in the form of lambda is to 1. One thing you must be knowing that M is to N, okay, is actually equal to M by N is to N by N, because we are dividing both sides by N, both the ratios component by N. That is equal to nothing but M by N is to 1. So why I'm saying so? If the ratio is in the is M is to N, then also we can say it is in the form of lambda is to 1 by keeping m is to n in the form of m by n is to 1. Now, what is our task? Our task is that to derive a section formula. What is meant by that? It is meant by that if we know the coordinate of the point A and B, suppose the coordinate of the point A is given as x1, y1, coordinate of the point B is given as x2, y2, and there is a point P in between the line segment AB such that AP is to PB is equal to lambda is to 1, we need to find the coordinate of the point P. This is our task at hand. Okay, dear students. So what we are going to find it now? We are going to find that section formula that we are going to discuss now. And for that, we need to make a drawing and then I'll explain you. So the topic what I'm going to discuss is called the section formula. At any point of time, if you have any smallest difficulty, never hesitate to let me know about it. Okay, so first let me draw the diagram and then let me explain you what we want to achieve by means of this section formula. Okay, let me first show you the diagram. Let me first explain you in details what is meant by that. AB is a line segment. As you see, dear students, AB is a line segment with coordinate of the point A is x1, y1. Coordinate of the point B is x2, y2. These are known to us. That means the point A having coordinate x1, y1 is given to us. It is given to us. That means we know what is x1 and what is y1. Similarly, coordinate of the point B is also given to us x2, y2. That means x2 is known to us, y2 is known to us. And we get a point P in between AB such that AP is to PB. AP is to PB is equal to lambda is to 1. That is also known to us. The value of lambda is given to us. Okay. And what we are going to find, dear students? We are going to find the coordinate of the point P. So this is given to us, this is given to us, this is given to us. What we need to find? We need to find the coordinate of the point P. Suppose we assume that coordinate of the point P is x, y, and we need to find that value. And in the next 5 to 7 minutes, we are going to see that how we are deriving the value of x and y, that is the x coordinate and y coordinate of the point P, which divides the line segment AB in the ratio lambda is to 1 internally in terms of x1, y1, x2, y2, lambda and 1. Now, why it is called internally, dear students? It is called internally because the point P is in between AB. Okay, if the point P is not in between AB, it is point P somewhere for which you need to extend the line segment AB, then it is called an external. But we are not going to discuss now. We are just going to discuss about the internal section. Okay, that is where the point P is in between the line segment AB. Okay, and that's why we can say is that from here as we discussed in the previous point, that we know that P divides the line segment AB in the ratio lambda is to 1. So to find the coordinate of the point P, x, y, we need to do some construction. What are the construction? We draw a perpendicular, okay, from the point A. We draw a perpendicular from the point A, okay, on the x, that is the x-axis. A perpendicular from the point P to the x-axis, that is PM. So what you see that AL is perpendicular to AL. Let me use a different color. So that AL is perpendicular to OX, then BN is also perpendicular to OX, means from the point B, we draw a perpendicular to the x-axis, and N is the foot of the perpendicular on the x-axis. So BN is perpendicular to OX, and similarly, PM is perpendicular to OX. That means what? From the point P, we draw a perpendicular to the x-axis, and the foot of the perpendicular is M. So we get PM is perpendicular to OX. Now, what another construction we are doing is that from the point A, we draw a perpendicular to the BN. That means what? From the point A, we draw a perpendicular to the line BN, and we get the point Q as the foot of the perpendicular. That means what we get? We get here is that, that AQ is perpendicular to BN. AQ is perpendicular to BN, and also what we get is that this AQ is intersecting the line PM at the point R. Okay, and obviously it is very clear that AR is also perpendicular to PM. That's why. Now this is the construction. Whatever we wanted to do is done. Now, dear students, if we look into from the definition of the coordinates, what is the value of AL? The value of AL is equal to, y1, and value of y1, and value of OL is equal to x1. Value of BN is equal to y2. Value of BN is equal to y2, and ON is equal to x2. Correct, dear students? And value of PM is equal to y. Value of PM is equal to y. And what is the value of OM? That is equal to x. And by the way, we are going to find the value of x and y. Now, dear students, what we're going to do is that we're going to find the value of x and y. How we are going to find the value of x and y, that is actually is a point of discussion. Now, dear students, if you look into it from the fundamental concept of geometry, if you see what is the value of AR, the value of AR is nothing but the value of LM, and what we can say, LM is nothing but OM minus OL, that is x minus x1. Correct? So what I'm saying is that from this diagram, what you see is that, let me write it here. Let me write it here in a different color. Let me write it in this color. So this is one thing, one set of, distances we measured. Then what we are going to find first, LM. AR is equal to LM. AR is equal to LM. And LM is equal to OM minus OL. OM minus OL. And what is OM, dear students? OM is x and OL is x1. So that is equal to x minus x1. Here you found it out. Then next one is AQ. Dear students, if you find AQ is nothing but AQ equal to ln. AQ is equal to ln. And what is ln? ln is nothing but ON minus OL. ON minus OL. And what is ON? ON we know it is x2. So it is x2 and OL is x1. So AQ we found it out. In the similar manner, we can find the value of PR. We can find the value of PR, dear students. So what is the value of PR? PR is equal to, what we see is equal to PM minus RM. PM minus RM. Now what is the value of PM? PM we know Y. Correct, no? And RM, so it is Y. RM is what? RM is nothing but AL. AL is nothing but y1. So it is y minus y1. I hope you got it. PR, we found it out. And the next one is we're going to find is that BQ. And dear students, if you find BQ, what is the value of BQ? BQ is equal to BN minus QN. So it is BN minus QN. Now what is the value of BN? The value of BN, we know Y2. And what is the value of QN? QN is nothing but AL, right? So what we get is that, BQ is equal to Y2 minus Y1, correct? So these are the values derivation we get, and it's very simple. Now you may have a question, sir, why all this derivation you are doing? We are doing all this derivation because, we are supposed to find the value of xy in terms of x1, y1, x2, y2, lambda. Hence, these are the, derivations we have done. After that, what? After that, dear students, we get two, triangles. The first triangle is that triangle BQA. Triangle BQA. And the next triangle is that triangle PRA. So what are the two triangles? Okay. Between the triangles, the first triangle is that BQA, and the triangle PRA, we get. So if you look into these two triangles are similar. Okay, correct? And why it is similar, that is very clearly visible. Okay, and as they are similar, okay, we get that between the triangles we get that angle, triangle BQA is similar to triangle PRA. Now as they are similar, so then what we can say, the corresponding sides will be in their equal ratio. That means what? AQ by AR should be equal to BQ by PR, and that should also be is equal to AB by AP. So what we can say, dear students, we can say AQ by AR, let me write properly. So this implies AQ by AR is equal to BQ by PR, that is equal to AB by AP, So now let's look into it. What is AQ by AR? We already all you found it out, dear students. If you look into it, we all found it out. What is AQ by AR? AQ, you found it out, x2 minus x1. Okay. And AR is x minus x1, correct or not? So what we get from here, let me write it down. So from here, what we write is that AQ, we already found it out, x2 minus x1. So x2 minus x1 divided by AR. AR is equal to, we get x minus x1. That is equal to BQ. BQ is equal to nothing but y2 minus y1. y2 minus y1 divided by PR. PR is nothing but y minus y1. And that is equal to what, dear students? That is equal to AB by AP. Now, as it is AB by AP, so what we can write, AB is equal to, we can write AP plus PB. That is equal to AP plus PB by AP. Now that is equal to AP by AP. That is equal to what? AP by AP. AP by AP is equal to 1. plus PB by AP. PB by AP, if you look into it, PB by AP, that is equal to nothing but 1 plus PB by AP is nothing but 1 by lambda, right? If you look into this diagram, AP is to PB is equal to lambda is to 1. So PB by AP is definitely equal to 1 by lambda. If you look into this, AP is to PB is equal to lambda is to 1 is given. Hence, we are writing PB by AP equal to 1 by lambda. And that is nothing but lambda plus 1 by lambda. Now, from here only, we are going to make the other derivations. So, dear students, what we get is that x2 minus x1 by x minus x1 is equal to lambda plus 1 by lambda. Correct or not? So, what we can say from here, we can write is that, so this implies x2 minus x1 divided by x minus x1 is equal to lambda plus 1 by lambda, and y2 minus y1 divided by y minus y1, that is equal to lambda plus 1 by lambda. I hope it is absolutely clear. Now what we are going to do, now we are going to make a simplification, because our target is to express x in terms of x1, x2, lambda, and our target is to express y in terms of y1, y2, and lambda. And let's see how we are going to do it. So if you see this first one, this implies x2 minus x1 by x minus x1 is equal to lambda plus 1 by lambda. So from here, we can simply say that x minus x1 is equal to lambda into x2 minus x1, lambda into x2 minus x1 divided by lambda plus 1. And in the similar manner, we can write y minus y1 is equal to lambda into y2 minus y1 by lambda plus 1. I hope it is absolutely clear. So then, what we can write from here x? So from here, we can write x in terms of, so from here we can write x is equal to x1 plus lambda into x2 minus x1 by lambda plus 1, and we can write y is equal to y1 plus lambda into y2 minus y1 by lambda plus 1. Now we can simplify further. If we simplify further, what we are going to get? We are going to get something like this. So let's simplify it. So from here, what we get? This implies x is equal to lambda plus 1 into x1, lambda plus 1 into x1 plus lambda into x2 minus x1 divided by lambda plus 1, and y is equal to lambda plus 1 into y1 plus lambda into y2 minus y1 divided by lambda plus 1. Now let's simplify a little more. So if we simplify, then what we are going to get? We are going to get x is equal to lambda x1 and lambda x1 will get cancelled. So we get x1 plus lambda x2. So we get x1 plus lambda into x2 divided by lambda plus 1. And we get y is equal to, in the same manner, y1 plus lambda into y2, y1 plus lambda into y2 divided by lambda plus 1. So we are able to express that x and y in terms of lambda x1, x2, y1, y2, because these are the quantities, that is x1, x2, y1, y2, lambda are known to us. And with these known quantities, we are able to find the value of the coordinate of the point P, that is x and y, is like this. So from here what we get, so we can see the coordinate of the point P, the coordinate of the point P is x1 plus lambda x2 divided by lambda plus 1 and y1 plus lambda y2 divided by lambda plus 1. And this is a very important observation, and that was our objective, to find the coordinate of the point P. Now what we are going to do is that, how to remember this thing. We are just going to learn the technique to remember this thing, how we can apply this formula. Okay, now the way to apply this formula is that, okay, then is that let's draw the line segment here. Let me draw the line segment first. Let me use a different let me use a different color. Suppose this is the line segment AB. Okay, and we know the coordinate of the point A. We know the coordinate of the point A is x1 comma y1, which is given to us. We know the coordinate of the point B as x2 comma y2, that is also given to us. And we know a point P in between AB. Remember, dear students, the point P is in between AB and its coordinate is x comma y. Its coordinate x comma y, which we do not know, we need to find. But one thing we know, that AP is to PB is equal to lambda is to 1. So how to find it out, dear students, is that, as you see, what is x? I'm just helping you to how you can remember this one. So it says that first you write lambda into x2. So lambda with, let me use a different color. So it will be something like this: lambda into x2 plus 1 into x1. Okay, so what we can write is that, lambda into x2 plus 1 into x1, 1 into x1 divided by whatever is there, lambda plus 1. And similarly, we can find y is equal to, in the same manner, lambda into y2 plus 1 into y1 by lambda plus 1. So this is the technique to remember. Now, dear students, whenever you get questions, in the questions you will find that the point P, which is in between AB, dividing the line segment AB in the ratio of m is to n, not lambda is to 1. But not a big deal. If the ratio is given as, if I use a different color, if it is given as that AP is to PB, if AP is to PB is equal to m is to n, this is the general way it is expressed. Not a big deal. So from here we can write that AP is to PB is equal to m by n is to 1, because we are dividing both sides by n. So then what is the value of x you are going to get? So under this condition, the value of x we are going to get, lambda is equal to what? Lambda is equal to m by n. So m by n into x2 plus x1 by m by n plus 1. And what is the value of y we are getting, dear students? The value we are getting y as m by n into y2 plus y1 divided by m by n plus 1. So now, dear students, if we simplify a little bit, what we are going to get? We are going to get x is equal to m into x2 plus n into x1 divided by m plus n. And we get the value of y is equal to m into y2 plus n into y1 divided by m plus n. Since n is not equal to 0, that's why we are able to divide by n. So what we get? A very effective statement we got. Effective in the sense, because whatever the questions we are going to get, dear students, that will be in the ratio of m is to n. So what's the conclusion we can write? So I'm going to write this thing. Let a x1 comma y1 b x2 comma y2, okay, and p be a point, okay, p be a point between AB, between the line segment AB, I can write in more proper way, between the line segment AB, such that AP is to PB is equal to M is to N. Then what you can say is that coordinates of P is coordinates of P is what you can write, M into x2 plus n into x1 divided by m plus n. That is the x coordinate, and y coordinate will be m into y2 plus n into y1 divided by m plus n. And this is a very, very important observation. And this is the concept, dear students, you need to apply moving forward. Okay, I'm just going to give a pictorial description of whatever I just wrote. So it says that if I draw the a line segment is something like this. Let me draw the line segment first. Suppose this is the line segment AB. This is the line segment AB, A and B. You know the coordinate of the point A as x1 comma y1, and you know the coordinate of the point B as x2 comma y2, and P is a point in between AB such that AP is to PB is equal to M is to N. Correct? Then how to find it out? In the same manner, dear students, is that M should be with this one. After that, plus N should be with this one. That means if you see what we are going to get, the coordinate of the point P, as we see the coordinate of the point P, we are writing as, let me write in a different color, as x comma y. So what will be x? X we can write is that, x we are going to write is that m into x2. From m we point to the B, means from when we take m, then we point to this one. So that is equal to m into x2, plus n, when you take n, then we point to the point in a coordinate of A, m into x2 plus n into x1 divided by m plus n. and y is equal to, in the same manner, dear students, m into y2 plus n into y1 divided by m plus n. And this kind of uh, section, that is also known as, it is, when that point P is internally you know uh, making a ratio of the line segment AB. Okay, so what we can say? We can say that the P divides the line segment AB in the ratio m is to n internally. Okay, that internally statement important, dear students. When you feel the value of this importance, when you understand about what is external. So from here, what we can say? We can say is that, so in this entire situation, what we see is that, so from here, what we can say? We can say something like this, that this implies also P divides the line segment AB, divides the line segment AB in the ratio m is to n internally. Okay, and this is very important. Okay, now we are going to solve some problem together. Okay, and this is the summary of whatever we have discussed so far. At the end of the class, you have access to these video lectures. You can again follow, go through it once the class is over, and you think that everything will be very crystal clear. Now, before I go for solving a problem, I just want to explain you why I use the word internally. Why I use the word internally. Does that word internally have any significance here? Yes, dear students. So let me give you an example so that you understand the difference between internally and which is not internally, that is externally. Suppose A is a point with coordinate x1, y1. B is a point here with coordinate x2, y2. So these two are given to you, and P is a point here, and its coordinate is x, y, which is not known to you. But you know what is AP is to PB, that is, we can define either lambda is to 1 or m is to n. M is to n is the most practical thing, that's why it is better to discuss m is to n. And let's consider another situation. You see here, this is the point A with coordinate x1, y1. This is the point P with coordinate x2, y2. And dear students, the point P, so let me do one thing. Let me keep the point, just a minute. Let me keep the point B somewhere here. Suppose this is the point B with coordinate x2, y2. x2, y2. Now, the point P is not in between AB. That point P, which is, dividing that line segment AB, is not in between AB, but if you extend that point B, okay, suppose you get point P here and its coordinate xy, which is not known to you. But one thing is pretty sure, that here also AP is to PB is lambda is to 1. Here also AP is to PB is equal to lambda, is not lambda is to 1. Let me write m is to n. That means what? This entire thing is m. AP is m and PB is n. They are not exactly equal to m and n. They are in the ratio of m is to n. That means what you can say is that AP is mk and BP is nk. And here also AP is to PB is equal to m is to n. But there is a fundamental difference between these two, dear students. In the first case, it is called that P divides internally. So here P divides AB internally in the ratio m is to n. And here we see is that here is how we express. Here also we write P divides AB but externally. Externally in the ratio m is to n. But dear students, what we discussed today about the coordinate of the internal division, the point P when it is dividing internally. That is a similar way we can find the formula for the external division also. Okay, so what we can do is that I just, for the sake of completeness, I can write this thing is that we found it out. The coordinate of the point P is m into x2 plus n into x1 divided by m plus n, comma m into y2 plus n into y1 divided by m plus n. This is the coordinate. And external division formula we have not derived, but I'm just informing you for the sake of your knowledge, is that you can find that point P coordinate as m into x2 minus n into x1 divided by m minus n, and m into y2 minus n into y1 divided by m minus n. Okay, so what we derived today is that internal section, but what we didn't discuss is the external one, but that we'll discuss subsequently in some of the future classes. But what is important is that that you know both the things. Okay, now what we are going to do, dear students, we are going to solve some problem together. Okay, so that will make our understanding very rock solid. The first question what we are going to do is that there is a question something like that. The line segment, okay, AP has a point P such that AP is to PB is equal to 4 is to 3. Let me first give you one example so that we can derive it properly. Okay. And this question it came in 1 year, and that we are going to solve it. Dear Bhumika, do you have any doubt here so far? Absolutely clear?
No, sir, I understood.
Okay, great. Now, the point is that let's solve this problem together. Okay, what is the question here? The P divides the line segment A and B in the ratio 2:1. Find the coordinate of P. So what is that point? So first, it is better to draw a diagram, line segment. More than diagram, what I can say is a line segment. Okay, so this is a line segment. So here is the point A, and coordinate is -2, 1. And here is the point B with coordinate 1, 4. Now, the point P, okay, it's dividing in the ratio of 2:1. So suppose this is the point P. Its coordinate is not known to us. We are going to find it out. So let's assume the coordinate of the point P be x, y. And according to the question, how it is getting divided? It is divided in the ratio 2:1. So how to find, dear students, about the coordinate of the point x and y? To find x, what we will do? To find x, 2 should be multiplied with this and 1 should be multiplied with this, correct or not? So x should be 2 into the x coordinate of the point B, that is 1, plus 1 into x coordinate of the point A, that is minus 2, divided by m plus n, that is 2 plus 1. And what is the value of y in the same manner? 2 into y coordinate of the point B, that is 4, plus 1 into y coordinate of the point A, that is 1, divided by 2 plus 1. So from here what we get? From here we get x is equal to 2 minus 2 by 3, and we get y is equal to 6 plus 1 by 3. Oh, sorry, 4 into 2, 8. 8 plus 1 by 3. 8 plus 1 by 3. So from here we get x is equal to 0 and y is equal to 3. So this implies the coordinate of the point P we get as 0, 3. So this kind of questions will generally come, and we need to solve problem related to it. So now there is a special case from here we can derive. Think about that how we can find the midpoint. Finding a midpoint is also very easy. For example, let's look into this problem. If we need to find the midpoint means is that the midpoint is dividing the line segment in the equal ratio. Okay, so I can write it here how to find the midpoint. So I can write it here is that how to find the coordinates of the midpoint of a line segment. Okay, so let's discuss what is meant by that. So suppose we have a line segment. We have a line segment AB. Suppose this coordinate of the point A is x1, y1, and coordinate of the point B x2, y2. Now we need to find the midpoint. Suppose C be the midpoint of AB, and its coordinate we do not know. Suppose it is x, y. Now what is the, when we say that C is the midpoint of A and B, when we say that AC is to CB is equal to 1:1, dear students. So then how we can find the value of, x and y in terms of x1, x2, y1, y2? Pretty simple. We just want to apply the formula. Before applying, for the initial few days, you can just make that arc draw, that from 1 to B and from here 1 to A. So from here how we can find the value of x and y? So x should be equal to 1 into x2 plus 1 into x2 means 1 into x coordinate of point B plus 1 into x coordinate of the point A divided by 1 plus 1. And what is y? Y should be 1 into y coordinate of the point B, that is y2, plus 1 into y coordinate of the point A divided by 1 plus 1. So from here what we get? From here we get x is equal to x1 plus x2 divided by 2, and y is equal to y1 plus y2 divided by 2. This is the way we can find the midpoint of a coordinate of the midpoint of a line segment when you know the two extreme ends, coordinate of the two extreme ends of the line segment. Clear? Do you have any doubt, dear Bhumika?
No, sir.
Absolutely clear? Absolutely clear? Okay, great. So, so we need to solve problem related to this particular, what about the internal formula we have learned, and we are going to we will do in the more problem in the next class. But before that, I would like to give some exercises.